Perfect, great. So I think let's just dive in. Let's do this one particular question. It's on financial maths. It's actually from an IEB past paper. So you guys are welcome to take a look. And I think this is from 2019. So we can just double check that. This is from the 2018 paper. So we've got Ryan opened a bank account 15 years ago and with the intention of saving money for when he retires. So that's a fantastic start, right? And then what he wants to do is say, okay, the bank offers him an interest rate of 16% per annum compounded monthly for the first 5 years, and thereafter changed interest rate to 11% per annum compounded annually. So immediately when you see some sort of interest rate change or anything like that, we want to do a timeline sort of question, right? So we want to keep track of all the individual changes as we move along. All right, so we continue. Rian made an immediate deposit of 300,000 Rand upon opening the account and withdrew 500,000 Rand at the end of 13 years. So maybe he wanted to buy himself a nice car after 13 years. Calculate how much money you would have in the accounts at the end of the 15th year. So let's see how we would approach this one. So clearly we're looking at the 300,000 Rand deposited. There are no other deposits, but we're going to have to split this up into the 2 separate time periods. Okay, and notice how we are compounding this amount monthly. Okay, so compounded monthly, so that means we need to multiply our term length, or the number of years, by 4, the number of years by 12, and then we need to then look at the next bit of time, which is then compounded annually, which is just your standard compound interest formula. Right, so let's go through it. So the compound interest formula is A is equal to P times by 1 plus I to the power of N. And here, because we were looking at something other than annually, we're going to need to divide both the I and times by the N by M. Okay, so that's basically just to accommodate the number of periods that we're working with. Okay, so there's the first little bit. So that's going to give us 16% per annum compounded monthly, and our initial amount is 300,000. So we put in 300,000, 1 plus. Now you can do this using decimals. I like to work with the percentage sign. It's just a little bit more quicker, a little bit more efficient. And so I'm going to use that. Okay, so if you wanted to convert a percentage to a decimal, you just divide by 100, but I'm just going to type in percent on my calculator. So we got 16%, and then we divide that by 12 because we're looking at compounded monthly, and then the amount of time is 5 years, but then again, we have to multiply that by 12 because we're actually looking at 5 years worth of months. Okay, which is basically equal to 60. And so we plug that into our calculator and we should get a value of 300,000. You guys are welcome to check me. I'm not making any mistakes. To the power of 60, and we get the value of 664,142 Rand and 6 cents. So that's the amount we have after 5 years. Now, the next step is to change our interest rate and then apply that for the remaining 7 years, or in fact 8 years, because that'll take us to the 13th year. So if we look at this from a timeline perspective, we start off with a 300,000 Rand deposit. And then as we move along, we get to the 5-year mark. And that's where our interest rate changes. So then we need to adjust to 11% compounded annually. And then we move along, and then we see there's a withdrawal from the accounts on the 13th year. So we basically need to subtract 500,000 from whatever we have then, And then whatever the remaining amount is, we're going to have another 2 years of compounded annually interest that's added onto that. Right, so let's do it. So the next bit is we're going to now change our interest rate. So we're going to go A is equal to P times by 1 plus I to the power of n. Here I don't need to use the m because we're just looking per annum, not per month. It's P. And so that's going to be the 664,142.06. Try use the entire value that's on your calculator. Don't round off. Okay, you want to minimize rounding errors because the cents do end up adding up in the end. So 1 plus, and then we've got 11%, and that's to the power of 8 because there are 8 years between the interest rate change and the 500,000 Rand withdrawal. And that gives us an amount of, so I'm going to go answer times by 1 plus 11% to the power of 8. And now I have 1,530,540 Rand and 47 cents. Great. So now what we're going to do is we're going to take away that 500,000 Rand that he withdrew to buy his fancy car. And so our amount that we're going to have at this period is going to be 1,530,540.47 less 500,000. And this leaves us with 1,030,540 Rand and 47 cents. And then this amount we then have another 2 years worth of compound interest. So that'll take us to the 15th year, which is what the question is asking us. See, they're asking for how much does he have in his accounts at the end of the 15th year. Right, so last compound interest formula, A is equal to P, 1 plus I to the power of n. And again, it's still annual. We're not using compounded monthly here. So we take the 1,030,540.47, or your answer from your calculator. It's 473 if you're wondering. 1 plus our interest rate, 11%, to the power of 2. And that gives us a value of 1,269,728 Rand and 92 cents. Okay, is that fine? Any questions on that? Any questions? Hopefully everyone can hear me. Otherwise it'll be quite awkward to be talking to myself here. Okay, it doesn't look like there are any questions yet. That's great. When you guys have a question, just pop it in the chat. Okay, so now what we're going to do is we're going to move on to the next bit. Okay, all good here. Ooh, 2 questions. Amber, go for it. Please type. Okay, I'll come to your questions shortly. Let me just continue with part B. And then I'll come back to your questions. So obviously this bit is like grade 10 sort of financial maths. The complexity comes along when you're working with the whole timeline thing. So let's check. Cool. Oh, here we go. How did you know to use simple interest instead of future value or present value? I didn't use simple interest, I used compound interest here. So future value and present value, we generally use these when you're looking at the idea of annuities, right? So annuity is an idea of putting money into the future. So it's like constant repetitive repayments, not one lump sum in the beginning where you gain interest. I did divide 11% by 12. I didn't need to divide the 11% by 12 because they say it's compounded annually. All right, so you see, I think that's, okay, cool, sweet. Okay, and then back to the future value versus present value. So that's an annuity. So that's the future value is saying, I'm going to put away 5,000 Rand every single month. And so that's going to build up a whole lot of money, which is typically what someone would do for their retirement. Not put a lump sum and just hope that it gives them a good return. And then a present value annuity is all about having some certain amount of money that you'll use for a whole lot of repayments later. Okay, so that's the general idea behind it. We'll come to questions on those shortly. In fact, we have a question on future value coming up right now. Okay. And then hopefully the next question that pop up will be on present value annuities. Right, so we determined that this person, Rian, will have almost 1.3 million Rand at the end of 15 years. So let's move on to part B. So they said, if instead Rian had taken a retirement annuity, so here's the annuity question, over the same period of 15 years, and the insurance company had offered him 8% per annum compounded monthly, what would his monthly payments have been if he were to save an amount of 1,270,000 Rand at the end of the 15th year? So here we found what our target is. We want to have that amount after 15 years. So now they're basically saying, okay, how much do you need to put in each month so that we can get to this amount? Or, yeah, because they've highlighted in that they want monthly payments here, which makes sense. Generally, when you're putting money away for your retirement, something that we should all do, it would be a monthly repayment based on your salary. Okay, pro tip, I heard that putting away like a quarter to a fifth of your salary each month for your retirement will make you a happy person later on in life. Okay, so let's dive in. So here we're going to have to use the future value formula, right? Because it's a retirement, it's an annuity. We're looking for a retirement. We have a lump sum at the end. So the formula is F is equal to X times by 1 plus I to the N minus 1 all over I. Now here again, because we're working with monthly sort of things, not yearly time frames, we need to make sure that we are dividing everything by the number of months, so the interest rates by months, and then we're multiplying by N by the number of months in a year as well, right? So that means we're going to have the interest rate spread over the year in terms of months, and we'll have 12 times more number of periods of interest. Okay, right, so good thing we got that sorted. Cool. So let's dive into actually calculating. So the amount that they're saying that Rian wants to have at the end of his saving period, which is 15 years, we're going to have 1,270,000, and X is the monthly installment, the monthly payment that we need to make in order to get this amount. So that's what we're trying to solve for. So we're trying to solve for X. Sounds like some bad maths joke. And so it's going to be 1 plus, and then what is our interest rate? So they tell us that they're going to give us an 8% per annum. Okay, and this is actually a little bit more likely. So you'll see that a lot of businesses or companies that deal in finances want to actually give you more interest rate if you give them a lump sum in the beginning. Okay, that's obviously saying that you're taking quite a lot of risk on yourself by giving them all that money in one go. But if they taking irregular payments, there is less of a risk on you and more of a risk on them to provide that interest. And so therefore they generally offer a lower interest rate. So we're going to take our interest rate of 8%, and I'm going to divide that by 12, and I'm going to raise that to power of 15 years times by 12, and that's going to be all over. It's got a little minus 1, and then again 8% over 12. Right, if you guys are ever interested or wondering why this formula looks the way it is, it relates to geometric progressions. So it's and a summation of a geometric progression. Right, so there we go, we got everything in there. Let's find out what the square brackets are equal to, and then from there we can solve for x. I'll put an additional 0, Rion would be stoked. But then again, his monthly repayments would be insane. So let's plug in. So it's going to be 1 plus 8% over 12 to the power of 15 times 12 minus 1 all over 8% over 12, close brackets, and that gives us a value of 346.038 and some other digits. Keep the whole value in the calculator just so we don't have a rounding error. And then we're going to divide our 1.27 million by that amount. So therefore, x is equal to 1270000 all over the 346.038, etc. And we get an answer of 3,670 Rand and 11 cents per month. Okay. Right, any questions on that? So there's just a nice simple use of an annuity formula, so the future value annuity. Any questions on that? Can I move on to another question from another past paper? Okay, all good. Sweet. All right. You think you're good. What does that mean? Does that mean that you just need to practice a little bit and then you'll be fine? I hope it's that. Okay, let me just grab another question here for you guys. Right, so here's the next question that I would like to take a look at. Right, so the first bit of this question actually isn't really financial maths, but it is finances related. It's just looking at, just currency conversions, that sort of thing. But yeah, maybe it is worthwhile to just go through the whole question. You never know what they might ask. From what Mia's told me about your school is that you can really get any possible question. So the owner of a printing company has decided to purchase machinery from China. Good choice, probably cheaper. If the exchange rate is 1 South African Rand is 0.502 Chinese yen or yuan, calculate the total amount she will pay in South African Rand. So that's quite a simple calculation. We are purely just going to take our total amount in Chinese yuan, 63, and we are going to divide that by 0.502. Okay, the reason why I'm dividing and not timesing is that we're looking at a conversion from rands to Chinese yen. If they said 1 yen is so much rands, then we'd multiply. So it's basically because we're going from the Chinese currency to South African rands. So we divide, and so we get a value of, let's plug that in the calculator, 48163 divided by 0.502, and I get an amount of 956,500 Rand. on the dot. It's like they chose that value really well. The import charges amount to 5% of the value of the machinery purchased. Calculate the import charges in rands. So 5%, we're literally just going to multiply by 15%, sorry, by 5%. So it's going to be 956,500.00 times by 5%. In case you guys aren't sure about where the percentage sign is on your calculator, it's the shift left bracket. And that gives us a total of answer times by 5%. And I get 47,825 Rand. So before the owner of the printing company even gets the machinery, they have to pay almost 50,000 Rand just to import the machinery from China. Right. So therefore the total amount basically is 1 million Rands worth of machinery, if you include the import charges. So that's part A, that's part B. So let's look at part C. So the owner intends to use her savings to purchase the machinery, which includes the import charges. She currently has 225,450 Rand in her savings, accounts, earning interest at 9.5 effective. Okay, so effective interest rate is the amount per annum compounded annually. You might see some questions that talk about nominal interest rates. And that's basically like what you are kind of getting. If you look at, if you compounded monthly, for instance, your nominal interest rate would be like, it's just the interest rate for that. Then they asked, determine how long it will take before she has enough money in her savings to purchase the machinery, assume that the price of the machinery and the import charges remain constant. It's unlikely, but interesting. Right. So here we were looking at compounded annually. We're not looking at monthly, so that's quite a nice calculation. So, and it's per annum. 9.5%, there's our amount. So we need to basically determine how long we need to have the savings account going for to get the total of these two values. So let's first find the total, and then from there we can calculate the number of years that we'd have to have the savings account going for. And this is actually a logarithm style question. So we're going to have this 956,500 plus the import charges of 47,825, and this gives us an amount of 1,004,325 Rand. So this is going to be our A amount, like our total amount after all the interest has been added. Can you guys even see that? Yeah, you can. Okay. Let's move that along just ever so slightly. Okay, so now what we need to do, from this we say, okay, I know this is compound interest. Okay, and we are going to try and solve for n. So this is very much a matric sort of level question, right? Because we're going to have to use logarithms. Before, you probably had to use an approximation. So you would just try and figure out what value of n would actually give that to you. But thankfully, you guys learned logs earlier this year, so all should be good. So we're going to plug in our values. 1,004,325 is equal to our present starting amount, which is her savings account amount of 225,000 Rand and 225,450 Rand times by 1 plus, and our interest rate is 9.5%. We don't have to divide by anything because we're just looking per compounded annually, and we're trying to solve for n. So what I'm going to do is divide by the savings amount on both sides. So I'm going to get this 325 all over 225450. And that's going to leave me with a value of 1.095 to the power of n. So that's what 1 plus 9.5% is. Let's simplify the left. So 1004325 divided by 225450. That gives me an amount of 4.45 and a whole lot of other values. And that is equal to 1.095 to the power of n. Now, a really cool trick that you guys can do with logarithms, if you're feeling good with your algebra, a particular rule that you can use is, like for instance, when you square root both sides or you square root to get rid of a square, you can actually do the same thing with logarithms. So I can say the log of the left-hand side must equal to the log of the right-hand side. Okay, and then once you've done that, you can use a logarithm law to take this exponent and multiply it in the front. So the log of 4.45, a whole lot of values, is equal to n times by the log of 1.095. And then from here we divide both sides by the logarithm of 1.095 to get our value of n. So all of those numbers divided by the log of 1.095, and we get a value of n equal to divided by the log of 1.095, and I get an answer of n equal to 16.46 years. Now, depending on how they want you to answer the question, if we're looking for the number of years exactly, then I would round up, because we want to say at the end of which year will you be able to have the correct amount of money. So we can say n is approximately 17 years. So after 17 years, they'll have the correct amount of cash to pay for the goods from China. Any questions on the logarithms? Would anyone like me to show you a slightly different method that you may have learned at school? I just find that doing logs on both sides and just doing some algebra is really quick, instead of thinking about that log bottom, this button on your calculator. Instead of using this method, it tends to be a little bit more gross to type in. But judging on the no comments, I think we're good. Sweet. Let me continue. Right. So that's basically how long we'll need to wait. So 17 years is quite a long time, but then again, if you think about some machinery, they tend to last decades. So to upgrade it in that amount of time is pretty good. Other thing about printing is that you never know, the industry might change, and then so even though your equipment might last 30 years, replacing it maybe in 17 or 15 years is a good idea. Right, then part D. So the owner decides that she wishes to purchase the machinery immediately. She uses her current savings as a deposit and approaches a bank for a loan for the balance that she requires. So loan amounts, pretty standard for a business to do this. And so because we're looking at a loan, this is going to be a present value sort of thing. Loans work on that idea of you take away money, okay? And then every time that you do your monthly repayments as a good citizen or a good member of that bank, you pay your money, but the outstanding balance is then interest is added on. So basically, as you move along, your interest that is against you will decrease, but it still adds on, okay? Because the total amount outstanding still gains interest. And that's why the present value formula is so handy, because it accounts for all of this additional interest or the change in total as we move along. So she approaches the bank and asks for a loan. So the bank will offer a loan which must be repaid at the end of each month with an interest rate of 1% per month, compounded monthly over a period of 4 years. So here they're saying 1% per month, and that is essentially the I over M, right? So we don't need to account for that idea. We literally can just work with 1% as if it were 12% per annum. Right, so that's what we're going to do. So part D. Right, so calculate the monthly installments, assuming she receives the loan immediately and that the first payment is made after 1 month. So this is where your annuity formulae come into play. It's generally after a month of payments. So we're looking at the present value formula because it's a loan, and we're looking at repayments. So it's P is equal to X, open bracket, 1 minus 1 plus I to the power of minus N all over I. And now we just need to plug in our values and solve for X, which is our installment, how much we're putting in to pay back the loan. So the amount that she needs to take a loan for is obviously going to be the cost of the equipment less her savings deposit that she's putting in. So if we take a look, the total amount of the machinery is 1,04,325 Rand, less the 225,450 Rand that you put in as a deposit. And that is equal to X times by 1 minus 1 plus, what is our interest rate? Well, we know that it's going to be 1% for every single month. So that's going to be 1%. And we're looking at the number of years, so it's 4 years, but our periods are in months. So we need to multiply that by M, which in this case is 12 because we're looking at months. That's 4 times by 12, and it's negative. And then that must be all over the interest rate again, which is 1%. Right. And then I reckon we should just find out what the value of the square brackets is. So we've got 1 minus 1 plus 1%, and that's all to the power of minus 4 times by 12, and that's all over 1% as well. So that value is 37,97, a whole lot of other values. And on the left hand side we have 100,4325 minus 225450. That is 778875. And now what we need to do is divide by this 37.97 and to determine what our monthly installment will be. So we take that over, and so we determine that X is equal to 20,510 Rand and 77 cents. Okay, so that's the first part, that's part 1. Okay, everyone with me here? So I think this is, it's obviously the first one with the present value formula. Amber, is this all good? Because I know you're asking about when to use future versus present value. Does it kind of make sense? Loans, and we're looking for installments, present value, retirement, putting away money for the future, lump sum, future value formula. Okay. Judging by the silence, I'm going to say that this is outstanding. This is earth-shatteringly awesome. You guys are all understanding, which is great. Right, so then part 2, they say, calculate the outstanding balance at the end of 2 years, i.e. immediately after the 24th payment. Sorry if you already explained, but why 1% not divided by 12 for monthly? Cool, no problem. So the secret here is that they're saying 1% per month, compounded monthly. Okay, that's the difference. If you look at the previous questions, they say it is compounded monthly, okay, but it's 16% per annum. You see the difference? Yeah, okay, cool. So because it's 16% per annum, okay, then you have to divide it by 12 so you can get it, what is your percentage per month? And so that's why you go I over M, right? But because they've given you 1% per month, you already know what your monthly interest rate would be, okay? And so then you only have to take the number of years and times that by 12 for the period, the time frame. Okay, cool, you got it. Rari, is that, you good? Did you also get it? Okay, so it's basically all about, you just got to be really critical when you guys are reading these questions. I strongly suggest take a highlighter and color it in, but obviously highlighting the main aspects of the question. You know, whenever they talk about interest rates, time frames, these are like important pieces of information that you need to to just develop a good sense of what they're asking in the questions. I'll wait for you to give me some more insight, Rari, but I'm going to assume that made sense. Right, so let's take a look at this outstanding balance. And this is, again, another application of your future value formula. And this is actually quite a good one, right? You got it. Fantastic. You don't have to call me sir. Name's Kevin. Okay. All right. But thank you. I appreciate it. So outstanding balance is an application of the future value formula. And it's also an application of your compound interest. So we're going to say, okay, what is the total amount that we have to pay back for this loan? And this is where the compound interest formula comes in. Okay, because we're going to just say, okay, at the end of this whole period, boom, that's how much we have to pay. Right, so we calculate the outstanding balance at the end of 2 years, i.e. immediately after the 24th payment. So that means we're working with 24 months of repayments, and we already know that our interest rate per month is 1%. So that's going to be quite a nice formula. So A is equal to P times by 1 plus I to the N. And again, we don't really need to divide by M because we're looking at a per month interest rate. So what is our starting amount? How much do we borrow from the bank? And that is that 778875. And we've got 1 plus our interest rate, which is 1%. And notice how they talk about the 24th payment. So they already told us 24 months worth of payments, which is 2 years times by 12, which is 24. So I can just write 24 straight away. And that gives us an amount of, just going to check here. Okay, I get 988,964 Rand and 57 cents. So this is basically how much she will have to pay after the 2 years worth of, just straightforward payments. Okay, obviously we're not looking at a long term, but this is how much interest this initial amount has accrued after 2 years. And now what we're going to do is take a look at the future value formula and look at what our monthly payments would be. So we're taking what we got from the present value from our monthly installments, and we're going to work out how much is this worth after those 24 months, right? Because this is actually like you are putting away money, and so that should naturally grow a little bit of interest as well as you go along. So let's do our future value. and that is equal to x times by 1 plus I to the n minus 1 all over I. Our future value, we don't know. That's the whole point of this particular question. We just know what our repayment is. It's that x of 20,510 Rand and 77 cents times by, just going to move this down. Everything's about formatting. Okay, so that's going to be times by 1 plus our interest rate, which is again 1%. 24 months minus 1 over the 1%. And here we can calculate what our future value is. And we see that our future value is going to be 553,246 Rand and 43 cents. So after 2 years worth of monthly repayments at 20,000 Rand per month, the total amount has got to just over 500,000. And so our outstanding balance is equal to A minus F. Okay, so it's your final or your compounded interest less how much you've paid back with interest. So that's going to be 988,964.57 less our 553,246.43. And that gives us an answer of 435,718 Rand and 15 cents. Okay. Right, and there we have worked out how much we need to still pay after the 24th payment. Okay, so if she happens to get a little stipend or another investment that gained a certain amount of money, she would be able to settle the amount for the machinery then and there if she pays that exact amount. Okay, everyone happy with that? Any further questions? Unfortunately, I have kind of run out of time, but I'm actually quite glad that I managed to go through these 2 questions. I think it outlines all the key little points that you guys need to tackle matric financial maths. You can see it's got a little bit of everything. Notice that there was no depreciation in here. Okay, that's fantastic. I'm glad, Amber. There's no depreciation, so just remember that straight line depreciation is 1 minus I times n, and then your reducing balance is like your negative compound interest. I think I cover a question on that in my future value annuity video that I made, uploaded this morning. So you can take a look in the channel there. That's got a nice example for future value as well. Yeah, absolute pleasure. I'm glad you could learn something new, Tatum, or just, freshen up. And I believe you guys have a test tomorrow, that is correct? Sweet, glad. There's a test tomorrow, right? So good luck for the test, hope it goes well. And yeah, just keep a lookout for, absolute pleasure. Like I said, keep a lookout for any future videos. Leave some comments on topics that you would like me to cover. I'm happily go over the counting principle as well. Even though you're writing a test tomorrow, I can do it another day. I can make a video on it, so that'll help you guys for your mock exams and that sort of thing. And yeah, thank you so much for watching, everyone. And yeah, good luck. Cheers.